Okay, so to start with this, you have to know the meaning of this. If I have fx is decreasing, so what does it imply? So what function must I have to satisfy this fx is decreasing? Kevin, you know why? What must I do first? Okay, yes, fx is going down. So if you tell me fx is going down, I still cannot do anything because I want to find this. So I must get a function out from there. Yes, you're supposed to find. That means if fx is decreasing in whatever situation, this implies that f prime x is less than 0, correct? So now first must get the f prime x function. Okay, everyone should know how to get the f prime x function, correct? So your f prime x function should involve k. So now we do f prime x using quotient rule. X squared plus k v u prime minus u v prime. The whole thing over v squared. Okay, so I simplified the top. Be careful, expand. Okay, so I got this. Negative x squared, there's you get from here. Okay, minus 2kx plus k over x squared plus k squared. So now, so how am I going to analyze this situation? So because f prime x involves fraction, so I know that x squared for all value of x, x squared plus k squared definitely greater than 0. Anything squared definitely is positive. So therefore, f prime x is less than 0 if negative x squared minus 2kx plus k is less than 0. Agree? Hello? Class, are you okay? Okay or not so far? Okay, huh? So, okay, so now, good. Okay, so if it's okay, then now, that means this function is a quadratic function. Okay, can I just call this as y? Negative x squared minus 2kx plus k. So this is a quadratic function, correct? A quadratic function, and you look at the a is -1. So this graph will be this way. Am I right? Concave downward. Yeah. Parabola concave downward. So you want y to be less than 0 and it's concave downward, which means that if I draw the graph will be below the x-axis, correct? That means there is no x-intercept. So this implies no x-intercept. If there is no x-intercept, what does that mean for quadratic? Means b squared minus 4ac have to be less than 0, no real root. That is how you analyze. Yeah, so my b is negative 2k squared minus 4, a is negative 1, k is less than 0. So this is 4k squared plus 4k is less than 0. All right. So now to solve this inequality, for k, so what we do, we draw sign diagram. Correct. First we find the value of x, the value of k that make 4k squared plus 4k equal to 0, correct? So I have 4k, k plus 1 equal to 0. So I have two values of k. So k equal to 0 or k equal to negative 1. Then I draw the sign diagram for this. Negative 1 and 0, correct? So this is k. So here is a minus. Is it a minus? No, it's a plus because it's 4k. Hello? And here is a minus. This one you can use your graphic calculator already. Now you can use graphic calculator to help you. Plus. So now we want it to be less than 0, correct? So choose the negative region. So therefore, answer, your book answer is wrong. Are you okay? So during the exam, this is my explanation. During the exam, you can quickly do and get the answer. So your book answer is wrong. Are you okay? Okay. So I'm going to give you one more question about polynomial. Okay, shall we do together and you take some time to do first before I explain. Okay, so given, so today I'm going to discuss about polynomial fx equal to x to the power of 4 plus 4x cubed minus 16x plus 3. Part A, find the stationary point of y equal to fx and state the nature of the point or points. Okay, B, find the coordinates. Sorry. Find the coordinates of the inflection point or point of inflection of y equal to fx and state the nature of the point or points. Okay. And C, sketch the graph of y equal to fx, y equal to f prime x, and y equal to f double prime x on the same axis. Okay, I give you 10 minutes to do. Okay, I stop recording. Okay. Okay, now we have to understand that if we have a polynomial, okay, so fx is polynomial degree what? Degree what? Hello? Degree what? Azif? fx is polynomial degree what? Azif? Huh?
Degree 4.
Yes, degree 4. Do you know why? Because the highest power is 4. Okay? So you look at your f prime x. F prime x will be 1 degree lower because when you differentiate, correct? Power take away 1. Am I right? So f prime x will be polynomial degree 3. So for polynomial degree 4, maximum how many turning point? How many stationary point? Maximum. No, Shazana? I'm testing your memory on polynomial. If it's degree 4, it got how many stationary point maximum? 3. Maximum 3 because for f prime x is degree 3, correct? Maximum 3x intercept maximum. Okay, so this is something that we have to know when we look at polynomial. So why is it 1 degree lower? Because when you find the derivative is power take away 1. Okay, so I got this already. So now I want to know the nature of the sign diagram of the stationary point. What should I do? I put f. So you put f prime x, stationary point, f prime x equal to 0. Yeah. Then you use your scientific calculator, key in all this, you got this answer. So you want to know the nature of the stationary point, you have to draw the sign diagram of f prime x. So we will use this by the help of our graphic calculator. Okay, what are the numbers that I must mark on this line? Hao Xuan? What number must I put down? Hao Xuan, quick.
-2
Yes. One more?
1.
Okay, 1. So then you use your Y2 in your scientific graphic calculator to determine the sign. Okay, so that one, I think I shouldn't go any more. Everyone should know. I repeat many times already. So you got plus and minus. Am I right? Is my sign correct?
Yes.
Yes. No.
Negative, positive.
Yeah.
Yes, negative, negative, positive. You're right. So this is my sign diagram for f prime x. So, which means that my fx graph, look, go down, stop, go down. Am I right? So, this point, what is the name we give? If the sign
Horizontal
doesn't
inflection
change.
point.
Good. Horizontal inflection point. Or if you don't want to use the word horizontal, you can use the word stationary. Correct? Okay. Then if you look at x equal to 1, the graph is go down, stationary, go up. So what is the name given for this point? What is the name given for this point? Johan. Johan, quick.
It's the horizontal in wait.
This point, 1, x equal to 1. Here, Johan.
Okay. It is the local minimum point.
Yes, local minimum. Okay, we know it. So you see, that is how your sign diagram of f prime x help you. So now I know that when x equal to -2, my f -2, I don't have to sub in. I straight away go to my y1 there. I call out y1, then I put in. So what is the number that you get, Kevin?
I got 19.
You got 19. So now you conclude -2, 19 is the stationary inflection point of y equal to fx. Okay, so when x equal to 1, Kevin, what do you get for your f1?
8, -8.
-8. So you know that 1, -8 is the local minimum of y equal to fx. Done. Your part A done. Are you clear? Okay. So your part B, you want to talk about second derivative for inflection point, all right? So for part B, you differentiate your f prime x. Yeah, you differentiate your f prime x. So what do you get, Kiko? Faraki, what is your f double prime x function? Kiko, Faraki, quick.
I didn't do B.
How come? Now you
Because I got-
differentiate and let me see.
Okay. You get 12x squared plus
Good.
the 24x. Yeah.
That's all. Right? So you want to find inflection point of y equal to fx. So which means that f double prime x must be equal to 0. Am I right? So you have 12x squared plus 24x equal to 0. So now what you are going to do? You are going to factorize it, correct? Or you can put into your scientific calculator also can. Your A is 12, your B is 24, your C is 0. If not, this one is quite easy to factorize. You can just do that. Correct? So you got two values of x, there is 0 and x equal to -2. Do you realize that? This one appear here, it also appear here. That's why we call it stationary inflection. Yeah, so the other point will be non-stationary inflection point. So what I can do is now, I will straight away say when x equal to 0, okay, what is my fx? Can someone give me the answer? No? No one want to give me? Nicholas? We?
Yes.
When x equal to 0, what is f0?
3.
3. Okay, so I will say that 0, 3 is the non-stationary or horizontal also can inflection point of y equal to fx. Okay, the other one I don't have to count because I've counted here, correct? So but I have to write down -2, 19 is the stationary or horizontal inflection point of y equal to fx. You better get all this, huh? Your SAT2 definitely got one question on this. Okay, so I'm done with that. Part A and part B. So part C, I can even sketch the graph for y equal to fx, y equal to f prime x, and y equal to f double prime x without my graphic calculator because I have all these crucial points. Are you okay? So now you look at how I sketch without the help of a graphic calculator. Okay, so my fx function is x to the power of 4 plus 4x squared minus 16x plus 3. Okay, my f prime x sine diagram go this way. -2 and 1. Yeah, negative, negative, positive. So my fx graph go down, stationary. This is my fx graph, huh? Stationary, go down, stationary, go up. So this is roughly the shape, all right? So now I look at my f prime x, f double prime x. -2 and 0 here. So now this is another important point. So it's plus, minus, plus. So I know that this one, my f prime x, my fx graph will go like that now. Plus means convex, smiling, stop smiling. Then minus means turn to crying. So this is your x -2 here. So then at x equal to 0, then -2 is 19, huh? Then 0 is 3. Then after that, it continue to go down. Then after that, it go up. You see, I can sketch the graph already. Is it -3 just now? I got all the important point. Oh, -8, sorry. -8. So this is my y equal to fx graph look like. So that means now I prepare my axis. I let my y come over here a little bit. So you roughly know how the graph will go already. So 0, -1, -2, 1, 2. So there are a few important points that you have to put down. So -2. So I'm going to sketch my fx graph using blue. So here, -2. So I make a dotted line to help me after I rub off. So I mark down. -2, 19 up here, right? Okay, that is my horizontal inflection point. Then it changed the shape at 0, 3. So if this is 19, 0, 3 will be around here. Okay, then it turned at 1, -8. So now I make a line here again to help me as a guideline. So when you sketch a graph, you must have a lot of guideline. Yeah. So this is not vertical asymptote, it's guideline. So it passed through here, around here. And this point is 1, -8. So now I can draw my graph. You see, it goes stationary. Yeah. Then here crying. Then after that, here turn convex. Go up. Go up like that. My x-intercept may not be that accurate. So this is my y equal to fx graph. Okay, now based on my y equal to fx graph, I also can get my f prime x graph even without the sign diagram. So look at here. I know that my f prime x graph, I use red, f prime x graph, because this is stationary, so will pass through this point. And it's also inflection. So it will pass through this point. So that means it will touch this point. It will not cut, it will touch. But this one, it will cut. And you look at here, it's go down. So negative, from very negative, touch. So it won't go up. It turn. And it doesn't go down straight away. So it has to have another inflection point here. Yeah. Right? Hello? Am I right? Oh, the inflection point is here. You have to go down. You cannot go down like that. Because here you have to turn. Because this is a horizontal inflection point. You see, it turned at x equal to 0, the red one. So it turn, it go like that, then it start to learn, go concave, then it go up. Hello, student, are you okay?
Okay.
So it's a skill. So it go, come down until here you have to turn, then it go up. So that means this is a turning point. So that means your y equal to f prime x got 2 turning points because your f double prime x got 2 x-intercept. So now your f double prime x is quadratic, correct? So quadratic. So your f prime x is going up, means your f double prime x is positive. So you start from here, positive, cut here, symmetrical. So you go here, then you go up there. So this is your y equal to f double prime. So during the exam, I can give you this graph and ask you to sketch the other two. So I hope you will go to Times and get the curve property exercise. Can you please? There are two exercises for you to do. All on curve property. An answer is provided also. Hello, so class, during this 4 days holiday, please make sure you complete your exercise 3B, 3C, 3D, and also the one in Times. So that hopefully next week, I can answer some of your questions that you may not be able to solve in your exercise, and I can get into the application of differentiation. 3B, 3C, 3D. Yes, you're right. And also go to Times chapter, I think topic 3, whereby I put that curve property exercise. Can I not? Student, enjoy your holiday, but remember, holiday only for those who are not students. Students, you only have holiday after your what? After your exam is over. Okay? Yeah, I'm not trying to be mean, okay? Class?